Okay, welcome back, students. This is part 2 of problem set 1, 2. Okay, so we left off, we wanted to evaluate the endpoints of this function here. And we can find the domain by subtracting the rightmost endpoint to the leftmost endpoint. So we did our algebraic calculations here, right? We did our algebraic calculations here, and we got 12.8. 12.8. So let's see if let's verify that. So evaluate F2 of 0, the leftmost endpoint, and sure enough we get 0, and F2 of 4, and sure enough we get 12.8. Okay, we can see that here too. It's approximately 12.8. Domain 0 to 4, x-axis. Y-axis is the range, 0, the y values, 0 to 12.8. Okay, now let's move on to problem number 5. And we have to plot the graph in GeoGebra and save the files, problem set 1, 2. Let's go ahead and save right away so we don't lose any of our work. Save every couple of minutes. Okay, private for now. And then we want to give the y and the x-intercepts, the location of any vertical asymptotes, and we want to give the range. So for A, see problem set 1, 2 GeoGebra file for this graph. Now, if we look at the y-intercepts and the x-intercepts, the y-intercepts, I said it was 12 because I come up here and, oh, I'm sorry, we haven't graphed it yet. So we have to graph it. So let's turn this one off and let's input f5 of x equals function, open parenthesis, our expression, which is negative x squared, which is shift 6 squared, right key to escape, right arrow to escape, shift plus for x plus 12, comma, from 0, comma, to 5. That's our domain. And close parenthesis, enter. Okay, so now let's adjust the window a little so that we can see this a little more clearly. Okay, now the y-intercept, let's go back a little. The y-intercept we can see is 12. This is the y-axis. The function intercepts the y-axis, boom, at 12. So there's the y-axis. The y-intercept is 12, crosses the y-axis at y equals 12. What about the x-intercepts? Well, let's look. Well, because we restricted our domain to 0 to 5, this function does not cross the x-axis. Nowhere does it cross the x-axis. It's way up here. Its endpoint is way up here. Okay. So the x-intercepts do not exist. They never cross the x-axis. The function never crosses the x-axis. What about the vertical asymptotes? Well, this function, if we allowed it to continue, looks like it would continue onward, downward, and to the right forever. Also here, downward and to the left forever. So this is not approaching any vertical line. So there's no vertical asymptotes. So then we want to evaluate the range. And I was going to use the same technique, leftmost point, rightmost point. And I got this, I did all the calculation, and I said, wait, this technique only works for linear functions, or perhaps other functions too, but for quadratic, we need the maximum point of the vertex. Because if you can see here, this is our highest point here, and this is our lowest point. So how do we figure that out? So let's go to problem set 1 through 5C. For a sad face or concave down quadratic function, the maximum or highest point is at the vertex given by negative b over 2a. So here we do the calculations for the vertex. So we say that the vertex is negative b over 2a, where a is the negative sign. And in fact, I think I highlighted this already. So let me undo this. Okay, so the highlight didn't show up. So let me go ahead and highlight again back. Okay, so here A is -1, negative. B is 4. So that's why I have -4, 2 times -1. Our vertex is at x equals 2. And so we evaluate f of 5 equals 2, which is 16, which is our highest point. And we evaluate f5 of 5, which is 7, which is, you can see 7 is our lowest point. So then we have, then the range would be f5 of 2, our highest point, minus our lowest point, equals 16, minus 7 equals 9. So the range can be written either y equals 7 to 16 or f5 of x equals 7 to 16. And we'll talk about this function notation a little more in the future. Okay. So here, let's make sure that we evaluated correctly our range. So we have f5 of 2, which equals 16, and f5 of, what did we say? 5 equals 7. So, and if we subtracted those two, those numbers would be 9. So go ahead and save this again. You want to continually save your work so you don't lose it. And now we can show all of them if you care to. And you can turn them off. Okay, so these are the examples for problem set 1, 2. Good luck, and I'll be circling around to try to help you if you have any problems. Okay. All right. I'll see you next time.